At first glance, the U.S. economy looks strong. Growth has outperformed forecasts, tech stocks are soaring, and productivity numbers are at their highest in years. But underneath that glossy picture, something surprising is happening. Nearly all of that growth, the jobs, the investments, the productivity, is coming from one source: data centers and AI infrastructure. What used to be the quiet, hidden backbone of the internet has now become the single most powerful growth engine in the American economy. And it's reshaping everything from power grids and land prices to labor markets and government policy. So how did we get here? And what does it mean when the future of U.S. economic growth depends almost entirely on the machines that think for us? Let's start with the numbers. According to recent estimates from analysts and the Commerce Department, nearly 70% of all private U.S. investment growth in the past year came from technology infrastructure, mostly data centers, cloud networks, and AI-related construction. That's a staggering shift. For decades, growth came from traditional sectors like housing, manufacturing, or retail. But today, a single digital ecosystem, built around servers, chips, and artificial intelligence, is driving the lion's share of economic expansion. It's not just a tech story, it's a transformation of the U.S. industrial base. The data center used to be an afterthought, a nondescript building filled with blinking lights, quietly keeping websites and emails online. But in the age of AI, those facilities have become factories of intelligence. They no longer just store data. They process it, learn from it, and generate insights. They are where AI models are trained, refined, and deployed. And their growth has turned into one of the largest construction booms America has seen in decades. Microsoft, Google, Amazon, Meta, and NVIDIA are pouring hundreds of billions of dollars into new data facilities, from Virginia's Data Center Alley to new hubs in Texas, Ohio, and Iowa. Entire towns are being remade by the AI economy. Farmers are selling land to tech developers. Utility companies are reconfiguring power grids. Real estate markets are transforming as these silent digital factories pop up in rural fields and suburban outskirts. It's an invisible revolution, one that doesn't look like innovation at all. So what's driving this explosion? AI's hunger for computing power is insatiable. Every time an AI model generates text, processes images, or predicts outcomes, it uses enormous amounts of energy and processing time. The next generation of models, like OpenAI's GPT-5 and Google's Gemini Ultra, require data centers capable of training systems that process trillions of parameters. That kind of computing muscle can't run on ordinary servers. It needs specialized infrastructure, liquid cooling, ultra-dense GPUs, and constant access to high-capacity electricity. And that's exactly what's being built. The United States is now experiencing a once-in-a-century infrastructure boom, not for roads or railways, but for digital power. These projects are so large that they're now counted in GDP reports as core drivers of growth. It's a strange paradox. America's economic future now rests on buildings most people will never see, powering systems most people don't fully understand. But there's another layer to this story: energy. Every new data center demands staggering amounts of electricity. In some regions like Northern Virginia, data infrastructure already accounts for more than a quarter of total power use. Nationally, data centers consume around 4% of all U.S. electricity, a number expected to triple within 5 years. To keep up, utilities are rushing to add new power sources, from natural gas and nuclear to solar and wind. Ironically, AI is both accelerating clean energy innovation and increasing emissions at the same time. That's why experts say the next economic bottleneck won't be chips, it'll be power. Whoever controls energy supply will control the pace of AI growth. It's a feedback loop. Data drives AI, AI drives infrastructure, and infrastructure drives the economy. But the cost is measured in gigawatts. Then there's the land rush. Just like the oil boom of the early 1900s, the AI era is creating hotspots of development. In Iowa, farmland is being converted into server space. In Texas, empty desert plots are turning into mega campuses. States are offering billions in tax breaks and incentives to attract data projects. The result is fierce competition, not for consumers but for compute. But it's also distorting local economies. In some areas, home prices and utility costs are rising as big tech firms move in. Small towns are struggling to balance the promise of jobs with the strain on water and energy resources. The U.S. economy is quietly reorganizing itself around a new kind of industrial map, one defined not by natural resources, but by digital geography. Still, the payoff is undeniable. AI infrastructure is boosting productivity, generating tax revenue, and fueling demand for high-skilled labor. Electricians, engineers, and construction workers are in short supply. Universities are updating curricula to train data center technicians and AI hardware specialists. For policymakers, it's the perfect headline: America is building again. But beneath the optimism lies a deeper question. What happens when so much of the economy depends on one industry? History offers a warning. Every major boom, from railroads to oil to housing, eventually faced a reckoning when growth outpaced balance. The AI infrastructure surge could follow the same path. If too much capital flows into data centers, and AI monetization doesn't catch up fast enough, the US could face a new kind of tech bubble, not in apps, but in physical hardware. Already, some analysts worry that the scale of AI spending is unsustainable. Microsoft and Google are investing tens of billions annually in data center buildouts with no clear ceiling in sight. If that spending slows, it could drag down GDP growth, revealing just how dependent the economy has become on this single sector. But perhaps the bigger risk isn't economic, it's structural. When so much national growth comes from data centers and AI, power consolidates into fewer corporate hands. 5 companies, the same ones building these mega facilities, now control the majority of global cloud infrastructure. That kind of concentration creates vulnerabilities. A single policy change, outage, or cyber attack could ripple through entire industries. The very thing powering economic growth could also be its biggest point of failure. Still, this transformation isn't all doom and gloom. The rise of data center-driven growth marks a profound shift in how America measures progress. For the first time, productivity gains are coming from intangible assets: intelligence, automation, prediction, rather than traditional physical output. In a way, the US is entering the cognitive economy, one built on computing power instead of horsepower. And while the risks are real, so are the opportunities. AI infrastructure could unlock breakthroughs in science, healthcare, and climate modeling. It could make businesses smarter, logistics faster, and innovation cheaper. But the balance will matter. The economy of the future can't just run on data. It has to run on sustainability, diversity, and resilience. Because the quiet truth is this: America's economic engine is no longer made of steel or oil. It's made of servers, chips, and electricity. And as those machines hum louder, they'll determine not just how fast the economy grows, but who truly benefits from it. The US is building the brain of the modern world, one data center at a time. The question now isn't whether this will define the future of growth. It's whether we'll be ready for what happens when the entire economy depends on keeping that brain switched on.